to the PowerPoint. Boom. All right. Logarithmic functions. Okay. All right. Log base b of x is b to the y power equals x. So if y equals log base b to the x, then this to this power equals this. This to this power equals this. That's a logarithmic function. So if an exponential function's like this, a logarithmic function is its inverse. Okay? They're inverses of each other because they cross the line y equals x. All right. So if log base b of 0 equals 1, that's because b to the 0 power equals 1. Log base b of b has to equal 1 because b to the first equals b. So b to the by is y because b to the y equals b to the y. And a base to a log power is just that number. Okay? You'll get this a lot better once we start doing problems with numbers. Okay? So 2 to the x power. 2 to the negative third is 1/8. 2 to the negative second is 1/4. 2 to the negative 1 is 1/2. 2 to the 0 is 1, and so on. So if we take log base 2 of x, see how these numbers in this column are these numbers in this column, and these numbers in this column are these numbers in this column? They're just inverses of each other. Okay? When you trade the x and y, those are inverses. Again, you don't have to write anything like that down. If you don't have a base on a log, it's base 10. If there's no base down there, we assume that it's base 10. So 10 to the x will be its inverse. Okay? We can skip over that. So, solving this. What is this? Well, this is a base 10. Okay? So this is saying 10 to the fourth power equals x. So this is 10,000. Okay? So the log base 10 of 10,000 equals 4. That's basically what we're saying there. Natural logs. A base of a natural log is e. So e to the x and ln are inverse functions of each other. Okay? So e to the ln of x power equals x, and ln of e to the y power equals y, because they're inverses. So the ln of x goes like this. The log of x goes like this. They're very similar to each other. So, transformations. Do we do transformations? I don't think we do transformations in this section. I think that's tomorrow. So let's get out of that. And let's go into what we have in this. Boom. All right. So to solve a logarithm problem, you set it equal to x. So 6 to the x power equals 6. Well, 6 to the what power equals 6? 1. This one set equal to x. 7 to the x power equals 49. This to this equals this. Okay? So x must obviously be 2. 10 to the 16th. Well, what's the base of a log without a base on it? 10. So 10 to the x equals 10 to the 16th. So x obviously equals 16. If we put a 10 down there, 10 to the x equals 1,000. 10 to what power equals 1,000? No. 3. 10 to the third power. 10 times 10 times 10 is 1,000. Okay? Again, another 10. 10 to the x equals 10. Instead of using the cube root here, what is the fractional exponent for taking the cube root? 1/3. So 10 to the x equals 10 to the third, so x must equal 1/3. Ln of e. Well, e is the base. So e to the x equals e, so it must be 1, because x must equal 1. Ln of 1, here's an e. E to the x equals 1. What is that? Oop, geez. Then I write down the answer. E to the x equals 1. What does x have to be? 0. Anything to the 0 power is 1. E is the base of a natural log. E to the x equals e to the, what power is that? 7/9. So obviously x equals 7/9. When you have 10 to the log power, these cancel each other out, so it's just 3. These cancel each other out, so it's just 0.6. Okay. Tens and logs cancel each other out. E's and ln's cancel each other out. Then you have to know how to run your calculator. So you hit the log of 0.097 on your calculator to write the answer down. So there's a few calculator problems here as well. Okay. Solving for x. Okay. There's no log base down here, so the base is 10. Okay. So x is equal to 10 to the second power. Well, what's 10 to the second power? 100. 10, so 10 to the fourth equals 10,000. Yeah, you guys can do that. So there's 19 problems, but they're pretty basic and straightforward. And some of you who are in college algebra have just done stuff like this. When's your college algebra test? Tomorrow? Tonight?